Good day, welcome everyone. Today we're diving into one of the most important topics in Anachem, stoichiometry. So this lesson will show us how chemistry and math work hand in hand. We'll learn how to connect moles, mass, and a number of particles so we can understand how substances react in precise amounts. By the end, you'll see that every chemical equation tells a story of balance and proportion, and stoichiometry is how we read it. So for today's objectives, we'll explain the concept of the mole and its role in stoichiometric calculations. Let's interpret balanced chemical equations in terms of moles, mass, and volume relationships. Let's convert between moles, mass, numbered particles using conversion factors. We'll apply the mole ratio form or from balanced equations to determine quantities of reactants and products. Let's solve basic stoichiometric problems involving given and unknown quantities in a chemical reaction. Okay, class. Let's talk about stoichiometry. The word stoichiometry comes from the Greek stoichion and metron, which means to measure the elements. Stoichiometry is basically a quantitative study of reactants and products in a chemical reaction. Medyo tongue twister yung term, pero madali lang yan once we break it down. So basically, ibig sabihin ng stoichiometry is pagsusukat ng mga element. In chemistry, stoichiometry is the quantitative study of reactants and products. It allows us to calculate how much of a given product a reaction is expected to produce based on how much of the reactants are available. It can also let us calculate the mass, volume, or density if it is known, all moles of product given the mass, volume, density, and a number of moles of reactants. This is just like in cooking. So parang cooking lang ito. Kung alam mo yung ilang cups of flour and sugar ang gagamitin mo, malalaman mo rin kung ilang cookies ang pwedeng mabuo. That's the same idea in chemistry. Okay? Kaya it's very important, mahalagang chemistry kasi stoichiometry kasi ito yung nagbibigay sa atin ng exact proportions para maging tama ang chemical reaction. So why do we study stoichiometry? Stoichiometry helps scientists predict reactions and reaction outcomes. For instance, it allows for the calculation of the mass of products formed from given amounts of reactants, which is crucial for understanding reaction yields and efficiencies. It also plays a crucial role in drug formulation and delivery. It helps determine the optimal dosages of medications required to achieve therapeutic effects while minimizing side effects, particularly important in treatments like in chemotherapy. So in short, ginagamit ito sa drug formulation, lalo na sa pagtukoy ng tamang dosage ng gamot. Sa chemotherapy, as we've mentioned, kailangan eksaktong computation para effective pero safe pa rin ang treatment. It's also useful sa pag-check ng reaction yield and efficiency. So before we move forward on how to calculate problems involving stoichiometry, let's bear in mind these important notes. Molar mass has two decimal places. So take note of this in every calculation. Your molar mass, namely the compound mass, the formula weight, should have two decimal places. So all calculations must follow the rule in significant figures, and you've learned this in your prelims. Conversion factors and fixed numbers, they are not included in counting for the significant figures. So all answers, take note, must have units. It could be moles, gram per moles, milliliters, grams, whatever it is. So nakita na natin kung gaano ka-importante ang stoichiometry sa real life. Next, alamin natin kung paano ginagawa ang actual calculations in stoichiometry. So let's take on percentage composition first. Percent, as you know, this word is defined as parts per hundred. By mass, what percent of each element is present in a compound? That is the meaning of percentage composition. Any type of mass unit can be used to calculate this. That is, to find the percent composition of a compound, we can use either the relative units, just like the atomic mass unit or AMU, or other units just like grams. So basically the formula is the percentage of the element is equal to the total mass of the element in a given compound divided by the molar mass of the compound multiplied to 100. So how do we so what's the importance of determining percentage composition? Percentage composition allows chemists to determine the proportion of each element within a compound. So in chemical analysis, percentage composition helps chemists know how much of each element is present in a compound. So mahalaga to para ma-identify natin ang mga substances at maintindihan kung ano ang mga properties nila. So, in short, hindi lang to pang lab or laboratory. Useful din to sa daily life. Next, let's see how to solve for percentage after learning its practical applications as well. In everyday life, percentage composition is used in various applications such as nutrition labels on food products, where it informs consumers about the content of macronutrients and other components. It plays a role in environmental science, affecting air quality assessments as well, and fuel combustion efficiency. So, ginagamit natin to sa everyday life din, di ba? Just like when you're buying food and you are reading its nutrition labels, nakikita natin ang percent ng protein, ng fats, ng carbs. It tells us what's inside the food we eat. In environmental science, we've mentioned ginagamit ang Anachem to assess air quality and fuel efficiency para malaman kung gaano kaayos ang combustion process. Okay, so how do we determine and solve for the percentage composition of a substance? We'll have a few steps of this. The first one is to determine the atomic mass of all the elements in the compound in grams per mole. Next one is to find the molar mass of the entire compound. Third is to divide the component's molar mass by the entire molecular mass. You will now have a number between 0 and 1, and we have to multiply it by 100 to get the percent composition. So basically, we'll just have to follow the formula. Okay? Example, let's calculate the percent of hydrogen and oxygen in water. The first step is to determine the atomic mass of each element, and we'll calculate the molar mass of water. To determine the atomic mass of each element, you'll need to have the periodic table of elements. So we know that hydrogen and oxygen, their molar masses, or atomic masses, are presented in the periodic table of element. So we'll now have to calculate the molar mass using the atomic mass of each element. So since in your periodic table, the atomic mass of hydrogen is 1.008 gram per mole. In the formula H2O, there are 2 atoms of hydrogen. And so we have to multiply it by 2. So 2 times the atomic mass of hydrogen, 1.008, is 2.016. For oxygen, the atomic mass is 15.999. And since there's only 1 oxygen atom in water, so we'll just have to multiply it by 1. So we'll get the same number. Take note, you don't want to shortcut or to do the shortcut or to round off the numbers along the process. You need to round it off at the end of the process. Molar mass is calculated by getting the total or the sum of the atomic mass of each element times its number of atoms in a given compound. So for hydrogen, that's 2.016. For oxygen, is 15.999. So add the 2 numbers. So we'll get 18.02. Why 18.02? Because we said that the molar masses of the compounds must have 2 decimal places. So this time, we'll need to round off the number to get 18.02. And lastly, we'll make use of the formula. For each element in a compound, we'll need to have a separate formula for it or solution for it. For hydrogen, percentage of hydrogen is equal to 2.016 grams per mole divided by 18.02 grams per mole times 100. So the percentage composition of hydrogen is 11.19%. For oxygen, 15.999 grams per mole divided by 18.02 grams per mole times 100, it will give you 88.78%. So therefore, our conclusion, based on the calculations, water is made up of 11.19% hydrogen and 88.78% of oxygen. Okay? So how did we get this answer? First step is we need to find the atomic mass of each element in the periodic table. Letter B, the next step is multiplying that atomic mass by the number of atoms in the compound. So you need to know the formula of the compound. So for water, that's H2O. And then after that, get the total of the atomic mass times the number of atoms in a compound in order to get the molar mass. And after that, lastly, we'll use the formula. The formula is in the numerator, we'll need to get the total mass of element. The total mass of element again is solved by multiplying the atomic mass times the number of atoms in a compound divided by the molar mass. Okay. Let's try to figure out the percentage by mass of dextrose. Dextrose, the given formula is C6H12O6. And for number 2, we chose more hydrogen in terms of percentage composition. Butane, C4H10, or cyclobutane, the C4H8. And by how much? Okay. For number 2, this will be your assignment. Have to submit it by the next week or next meeting, which is in Wednesday or Thursday. For number 1, let's solve for this problem. First, let's calculate the molar mass of dextrose. Dextrose, C6H12O6, using your periodic table, we know that carbon has atomic mass of 12.011. So we multiply it by 6 because there are 6 atoms of carbon in dextrose. And then for hydrogen, times 12 because there are 12 atoms of hydrogen in dextrose. And lastly, for oxygen, times 6. So we'll get the total of the 3 atoms combined masses will give us 180.16. So this will be the molar mass of dextrose. After that, we'll use the formula for each atom. Percentage composition for carbon, for hydrogen, and oxygen. For carbon, 72.066 divided by the molar mass, 180.16 times 100 will give you 40.00%. For hydrogen, it's 6.71%. For oxygen, that's 53.28%. So this is the final answer for the percentage by mass of dextrose using each of the elements present in this compound. Now let's talk about the mole concept. The term mole literally means a small mass. It is used as a bridge between chemistry on the atomic and macroscopic scale. The word mole comes from the Latin word for pile or heap. A mole of any substance contains the same number of elementary particles as there are atoms in exactly 12 grams of the carbon-12 isotope or C12 isotope of the carbon found in the periodic table. In other words, the mole connects what we can see with what we can actually see. The SI unit for mole is simply mole without the E, MOL. Mole is based on Avogadro's constant, or we also call this Avogadro's number. 1 mole is equivalent to the amount of substance that has 6.0221 or 1,527 times 10 raised to 23 atoms or molecules. 1 mole of any substance will always be equal to that number above, simplified to 6.022 times 10 raised to 23 atoms or molecules of that substance. So, ang ibig sabihin, 1 mole of any substance will always contain 6.022 times 1023 atoms or molecules of that substance. Whether it's oxygen, carbon, water, dextrose, whatever it is, pareho lang ang bilang ng particles. So now that we know what a mole represents, let's see how we can use it in actual calculations. So how to determine the number of moles in a compound? We have the formula for mole. Mole is equivalent to mass of a compound in grams. Take note of the unit, it must be in grams. Divided by the molar mass of a compound in grams per mole. The molar mass of a compound, again, to solve for this, we just simply determine or use the periodic table for atomic mass, multiply the atomic mass to the number of atoms present in a given compound, and get the total for all the number of atoms, and that will give you the molar mass. Example, how many moles of hydrochloric acid or hydrogen chloride are there in 5.0 grams of hydrogen chloride or hydrochloric acid? So we'll just need to apply the formula. So mole of hydrochloric acid is equivalent to, again, in the numerator is the mass of the substance or compound in grams. That's 5.0. And then for the denominator is the molar mass. Since the formula is HCl, there's only one atom for hydrogen, and for chlorine, we just simply add the atomic masses of hydrogen and chlorine. So we'll get 36.46 grams per mole. So the answer is 0.14. Take note that we're following the significant figures for this. We'll only have two significant figures following the least significant figure for 5.0. Okay? Before we dive into stoichiometric process, we need to understand first and know balancing of equation. This is the requirement for us in order for us to solve reactions or chemical reactions. Remember that balancing follows the law of conservation of matter. It states that matter is neither created nor destroyed in every chemical reaction. What happens is that it is conserved. Conservation of mass or matter is actually equivalent to balancing. So how do we balance chemical reactions? Example, how do we make a balanced reaction when hydrogen gas and oxygen gas combine to form water? So there are simple steps in balancing. The most important thing about balancing is you know how to write the correct chemical formulas for each reactant and product. Remember your inorganic chemistry? In that subject, you should have a background knowledge for this, stock knowledge for this. And then write the skeleton equation for every reactant and product mentioned in the problem. Next step is to count the number of atoms of each element that appears as a reactant and as a product. If it is a polyatomic ion means a compound composed of many atoms in one is unchanged on both sides of the equation. Then you have to count it as a unit. The third step is to balance each element one at a time by placing coefficients in front of the formulas. Remember that there is no coefficient written for a 1. It is best to begin by balancing elements that only appear in one chemical formula on each side of the equation. As a general rule, never change the subscripts in a chemical formula. You can only manipulate and balance chemical equations using its coefficients. Remember this, because most of the time, this is one of the most common mistakes that students commit when they try to balance chemical reactions. The fourth step is to check each atom or polyatomic ion to be sure that they're equal on both sides of the equations. Then how to do this? We simply count the number of atoms. And counting is I think it's an easy it's a basic skill for every one of us. Make sure that all coefficients are in the lowest possible ratio. If necessary, we need to reduce it to the lowest possible ratio for the reactants and the products. So these are all the five steps in balancing, and let's apply these steps in the next problem. So let's go back to the problem. How do we make a balanced reaction when hydrogen gas and oxygen gas combine to form water? The first step we've mentioned is to determine the correct chemical formulas for each reactant and product. So let's try to write the chemical equation for this. So let's determine the correct chemical formulas for each reactant and product. Let's first write the skeleton equation for this. So since the compounds involved are hydrogen and oxygen, so we write the diatomic structure or formula for them: H2 for hydrogen gas and O2 for oxygen gas, combining to form water. That would be H2O as the product. The second step is counting the numbers of atoms of each element that appears as a reactant and as a product. So let's first count the number of atoms in the reactant side. So we have 2 hydrogen atoms for H2, and for oxygen there are also 2, and in the product H2O, H2 means 2 atoms and O with a subscript 1 means 1 atom. As you can see, this is not balanced yet because there are 2 atoms for each hydrogen and oxygen, but there's only 1 atom for oxygen in the product side. So to balance each element, we have to look at each element one at a time and balance them by placing coefficients in front of the formulas. Remember, no coefficient is written for a number 1. So since there is only 1 oxygen in the product side, let's try to multiply it by 2. So we write 2 as a coefficient. Remember, the coefficient is a multiplier for each atom in a compound. So if you write 2 as a coefficient, that would mean H2 is multiplied by 2. So 2 times 2 is 4. And for oxygen, 2 times 1 is 2. So take a look at the equation. So we have the reactant side, 2 hydrogen and 2 oxygen. In the product, we have 4 hydrogen and 2 oxygen. So the oxygen atoms are equal now, but the hydrogen atoms are not. But if you observe it in this chemical reaction, 2 and 4, or 4 is a multiple of 2. So that simply means we just have to multiply 2 in the reactant side for hydrogen in order to come up with 4. So 2 is written as a coefficient for hydrogen gas. So that means 2 is a multiplier for the subscript 2 for hydrogen. So 2 times 2 is 4. So now, make sure, check each atom or polyatomic ion to be sure that they are equal on both sides of the equation. So we have checked them already and they are equal. And make sure that all coefficients are in the lowest possible ratio. So the ratio of all the coefficients here is 2:1:2. So that's the lowest possible ratio na already. And therefore, this is the balanced chemical reaction for hydrogen gas and oxygen gas combining to form water. In this slide, there are 5 items and I want you to balance these chemical reactions. Write your answer in a one whole sheet of paper.